Basic Architect. We're out here at our Build Show Build Boston site. I'm walking tall today. I took the electrician's switch stick. If you're wondering what a switch stick is, it's basically a stick that they cut so they don't have to measure the box height. They just basically set the boxes on top of their switch stick and nail them off. But we're not talking about electrical today. Today I thought we would talk about a little potpourri about framing. This is the owner's suite here, the owner's bedroom, and there's a whole bunch of things happening here. So I figured, why don't we just take some time and look around and have a little chat, right? So we'll start out with the back wall here. We have our back wall. It's a 2x6 wall. It's 24 inches on center. So 24 inches means the spacing of the studs here. Traditionally, you could do it 16 inches or 24 inches on center. The difference is a framing factor of probably somewhere around 7 or 8%. And what I mean by framing factor is if we took all of the exterior wall of the whole house and put it in one large polygon, it would be made up of basically three things, right? There would be the opaque area, which is where all the framing members are, whether they're sills, studs, bottom plates, top plates. The second would be doors and windows, where all basically the openings are, and they're filled in with doors and windows. And then the third would be the cavity space, right? So, by moving from a 16-inch to a 24-inch space, we basically expand the cavity space by about 8%, which means we diminish the opaque framing by about that 8% or so. It depends on how much wood framers put in their traditional. These are some rough numbers, but they are pretty accurate across the board. So here we have 24 inches on center. We also have zip R9 sheathing on the outside there. For those of you that aren't familiar with that, it's the standard 7/16 inch zip. But to get the R9, there's 1.5 inches of poly isocyanurate that's laminated to that zip sheathing and gets installed on the outside of that. So think of it as we put a giant sweater all around the house. Now, how does that help? Well, let's go back to our model. If we take all the exterior walls, we put them into one big polygon. Remember, we have the opaque area, we have the cavity area, we have the doors and windows area. Well, the door and window area, I can't do much about because we're going to put a door or a window in there and we're just going to live with whatever that R value is. But at the cavity area and the opaque area, I can bump up that insulation number. So a standard 2x6 is probably somewhere about 5.8, R5.8, R6-ish. It's somewhere in that number. I believe it's about 1.25 per inch for spruce pine for framing members there. But anyways, it's somewhere in there between 5 and 6. Doesn't really matter. The ability to put the zip R9 on the outside now means at all of the opaque area, I've just added R9 so that across a section right here, I go from that R5 or 6, if that was just a standard framed wall with plywood on the outside, to adding the zip R9. I add the R9 and instead of being 5 or 6, now it's 14 or 15. So it's significantly a better insulator. It's literally, I put a jacket around our structural system, right? I just recently heard a really good analogy. I mean, you think about it, our bodies, we use fat as part of our insulator, right? In our bodies, does our fat go over our rib cage or does it fit in between all of our ribs, right? It goes over, obviously, because it works better as an insulator that when it's all around, right? So, the cavity also, in a standard cavity here, we're probably somewhere at around R21. But adding that R9, now that bumps us up to R30. So we get another 30% of R value in the cavity. And the cavity and the opaque area probably make up about 80% of that giant polygon that is the cumulative effort of all of our exterior walls. So 80% of our system has now been bumped up, say 30-ish% or more, depending on whether it's the opaque framing or if it's the open stud framing. But anyways, that's the benefit, the down and dirty benefit of using a insulated sheathing on the outside. And it comes in many forms. Zip R9 is one of our favorite forms. We use it a lot. We used it out here. So 2x6s, 24 inches on center. You can see we have our sills here. This is just a cripple. This is our bottom plate. The cripple is nothing more than a common stud that gets cut to support the windowsill or some other function here, but it's not a full-length stud like, say, this one. This one is just basically a common stud. And then we have our cripples. Alongside the window, you'll see we have double jacks. Some people call those trimmers. Basically, they are the support for the header, the piece that goes over the top. And then they basically always have a king stud that runs up the side. The king stud is, you can see, it's nothing more than a common stud. The reason it changes its name is because it becomes part of the rough opening assembly. So it switches its name from common to king there. We have our header here, and then again, we have some cripples up above, and then, of course, our double top plate there. You can see above us here, we have an open web roof truss. And this one actually has a sloped bottom cord and a sloped top cord. The top cord is at about a 3 pitch. The lower cord here is at about 1.5 pitch. And when I say 1.5 pitch, what I'm saying is for every 12 inches horizontally, it'll rise up 1.5 inches. Likewise, on the top part of that roof, for every 12 inches it goes over, it rises up 3 inches. Now, notice here, we also, because of the taller walls, we actually switched to using an LVL framing here, rather than using the standard stud here that you would use for, say, our 9-foot walls. As these grow, we wanted the structural integrity to be just a little bit better, but we wanted our walls to stay nice and straight, so we moved to an engineered stud. These are by Roseburg. They're rigid lamb LVL. They're basically made exactly the same way LVLs are made. They're just cut into stud work instead of 20 or 24 inch LVL beams. You can see here in the large window, it was really important that we use again that LVL framing. I mean, this window rises up to a head height of probably somewhere around 11 feet. So we want to make sure these are acting like a nice strong column, but that wall is going to stay nice and straight, as well as it can combat any wind that gets pushed up against it with this large window in there. The other thing to notice in these windows here, as well as the one in back that I was there, we actually have double jacks. So in our drawings, it actually calls out in the header schedule for any window that exceeds 36 inches. So if it's 36 1/8, then you have to move to a double jack system. And that comes from our structural engineer also. So 3 foot and below, we would just do a single jack. 3 foot or above 3 foot, we move to the double jack. And of course, you can see we have our king and our common stud there, our window installed. We have all of our cripples here. You can see here we switch back to the standard framing there, but we stay on our 24 inches on center all around. Last but not least, notice we talked about the zip R sheathing on our exterior wall there. But notice up here where we have our flat roof comes into our cheek wall. Notice that our zip R sheathing comes all the way down and it marries up with the bottom of the roof, right? The roof framing does not get framed into the cheek wall and the R sheathing brought down to the top of the roof. It's vice versa. The roof sheathing is brought down all the way to the bottom of the roof frame here. And then the roof is framed up against it and then flashed properly. That ensures that we get a nice thermal transition from the insulated space of our flat roof system transitioning into our vertical wall system of that cheek wall. Anyways, that's a quick potpourri of standing here in the owner's bedroom, checking out some of the framing. This is Build Show Build Boston site. I'm Steve Basic. It's a beautiful day. Go out and enjoy it. Until next time, long live our building.